So we've got y equals, well, we've got what y equals ax cubed plus bx. So dy by dx equals 3a squared plus b.
Say it again, sorry. 3a.
So 3ax squared.
Yeah.
B.
Plus b, okay, yeah.
So now we've got a y value, so we've got 1 and 8. So that means that 8 equals 3a times 1 squared plus b. And we can work out b because m equals 12. So we have to say that 3a times 1 squared equals 12. 3a equals 12, so then a must equal to 4.
Okay.
And we need to find b as well. So we've got 8 equals 3 times 4 times 1 squared, which is just times by 1, plus b. Therefore, 8 equals 12 plus b. So b must be 8 minus 12, that's minus 4.
So I think you're okay for that. So 3a plus b is 12. And a plus b is equal to 8. Do you know which calculator do you have?
I've got the the ClassWiz one, yeah, that one.
And do you know how to do simultaneous equations with it?
Yeah. Would you mind I just go and get it? Sorry.
Okay, yeah.
I've got a spare.
There's a new one. None.
Table.
It's the table. You carry another person from the other room. I'll show you the table. Where's that one? Why don't you quickly go upstairs and put sugar on the table? Yes, upstairs.
Okay, sorry, Dara. Just bear with me 1 minute, and I'll be.
Okay.
Is it there? Yeah, I saw it was on upstairs.
I've got it here. Yeah, it's fine.
Okay. And so
Yeah. I think was it simultaneous equations we were trying to do?
yeah.
Okay, so we've got three. Yeah, so 3a plus b equals 12. How did we get that?
So I think that's what I put in. I wasn't sure. So, oh, the y coordinate is 8, so that's equal to 8. Sorry, is it 3? No. That was the 3ax squared plus b. So when you sub in 1 for x, yeah, you get 12.
Yes, yeah. So yeah, 3ax squared plus b equals 12. When 3a plus b. So that must be 12. Yeah, and then a plus b equals 8. And so yeah, because how did we get the 3a the a plus b equals 8?
So if you sub in 1 for x into the original.
Oh, into the original equation. Okay. So yeah, we've got these two equations, and we just go to alpha a, and then you go to simultaneous equation, 2 unknowns. Yeah. So then you've got 3x plus then you just got 1. So you've got your A equals to 2, and then your B equals 6.
That's it. And so, yeah, I just wanted to check. I'm sure you can do it the manual way, and just wanted to check that you know the calculator way as well. Any questions there?
No, that's fine.
Okay, so that was 10, so you're mostly okay for that. How about 11?
So number 11. Okay. Show the tangent y equals x cubed plus x plus 2. So show the tangent to the curve there. Okay, so I might just draw a sketch of it just beforehand, just to see how I can do this. So it's a cubic graph, and we've got the intercept as 2. So it passes through. X coordinate. So you find the area of it. Okay, so the tangent to the curve x cubed plus x plus 2 at point P, when x coordinate is 1, passes through the origin. Find the equation of the normal at this point. Okay, so the tangent, so we have to find I think we have to dy by dx. That equals to 3x squared plus 1.
Mm-hmm.
Got x equals 1 at this point, and we need to find the m, so that's just 3 times 1 squared plus 1, which gives us 4.
Mm-hmm.
I'm looking here. So we've got the m and the... We want to find the equation of the normal at this point. So we've got m, and now we need to use y equals mx plus c. We've got any... No, we don't have any other things. So we've got m1, yeah, so m1 equals 4. And we could say that the m of the normal, m2, equals minus a quarter.
Mm-hmm.
And we've got the m. We need to show that it passes through the origin when x equals 1. First of all, so we've got the first gradient.
Any idea how you got about that?
Yeah. We don't have any y, but we just have to substitute the x value in the original equation to get the y value.
Correct.
So equals, yeah, so y equals 1 cubed plus 1 plus 2. That just gives us 5. So we can use this, we can use our 2 coordinates 1, 5 to get the equation of the tangent. So y equals mx plus c. 5 equals m times 1 plus c, and we know our m is 4, so 5 equals 4 plus c. C then equals to 1, so c equals 1, so y equals 4x plus 1.
Okay. Into the curve. Two. And so how did you get 1?
I used y equals mx plus c.
And so what was the values you subbed in?
I used so I used y equals mx plus c, and then I used y equals 5.
Y was 1 cubed plus 1 plus 2.
Oh, sure. So it's 4, right?
Yeah.
Okay. Yeah. So 4 equals mx plus c. 4 equals 4 times 1 plus c. Therefore, c equals 0. So the equation is just y equals 4x.
Mm-hmm.
So we've got that equation, and we can prove that it passes through the origin because there's no y-intercept.
And the way I would prove it is I was sub-0 for x.
Sure. Okay. So y equals 4 times 0, which is y equals 0. Okay.
Yeah. Okay. And then we have to find the equation of the normal.
Yeah. Okay, let's find the equation of the normal. So we want the equation of the normal at this point. We've got our 0.15, and we've got our n value minus a quarter. So we just do the same thing again. So y equals mx plus c. So 4 equals minus a quarter times 1 plus c. So c is just 4.25.
Say it again, sorry?
4.25.
Yes. Yep.
Okay.
And so the equation of the normal?
Yes, so we got y equals minus a quarter x plus 4.25.
That's it.
Now what? So we've got the equations of the tangent. And given that the normal cuts the x-axis at point Q, find the area of triangle OPQ. So, right. Just give me 2 minutes to copy some of the stuff that you wrote on there on the screen, please.
Okay.
Mine's just a bit messy here, so. Right. So we want to find the area of triangle OPQ. So we need to then sketch the graph, I think. So,
Well, I don't think we found the point Q. But okay, yeah, can you sketch it first?
Yeah. So yes. So we've got there's it's a cubic, so it's gonna. I know the shape of a cubic, but I'm trying to think where would the. Okay, so we're trying to find the point Q. So then the normal cuts the x-axis at point Q. Find the area of triangle OPQ. So then this Q here. Yes. So how do I find Q? So y equals minus a quarter x plus 4.25, yeah.
Mm-hmm.
And then you just have to substitute 0 for x. No, 0 for y. 0 for y.
Correct.
So 0 is minus a quarter x plus 4.25. And then you can just solve it like that. So you've got a quarter x equals 4.25. So x equals just 4 times 4.25. Giving us 17. That's the cube. We've got 17, 0. And so the 1 4 was our coordinates for the for that point. So we got 1 4, 17 0, and then we got 0 0. So if we want to find the area of the triangle, we just have to find the length of each side. So we know that the length of the base I got is 17 because it's 0 to 17.
Mm-hmm.
And the height of this, so this is, we want to find the perpendicular height of the triangle. So this, okay, so I've kind of drawn, so you can use Pythagoras to get the side length of the triangle. Oh no, but we want the perpendicular height for the area. So we use just 4. We just use 4 here.
Yes.
And then you just use the equation half base times height. And that is 17 times 2 basically. So that's 34.
That's it. Well done. Any questions there?
No, that was quite long, but I think I got that.
I mean, it's a big question.
Yeah.
Okay. And question 12.
.39 plus the y-axis to 0.0 minus 9. Okay. So you just use y equals x squared and then dy by dx equals 2x. And at the point, so we want to find our m value. So 2 times, that's just 2 times 3 at that point, is 6. Y equals mx plus c. And then 9 equals 3 times, so 9 equals 6 times 3 plus c, so therefore c must be minus 18. So y equals 6x minus 18.
And so what is c?
Yeah, so we've got minus 18 for c.
I think it was 9 equals 6 times 3 plus c.
Yes. C is 6 3s are 18, right? So then you just minus 18 from both sides.
Yeah.
So also minus 9, yeah, minus 9. I don't know.
Yeah.
Okay. So we've got minus 9 for c. Y equals 6x minus 9. So we want, that's the equation of the tangent, and it crosses the y-axis at the point 0 minus 9. So that means you just have y equals 6 times 0 minus 9, and then y equals minus 9.
Yeah. Minus 9. That's it. Great. So I think, okay, how do we do this?
Okay, so they want the height of vertex A above BCD. So yeah, I'll just sketch that. Yeah. We want the height above the vertex, so that's 6. We can find the length, so you can kind of make a right angled triangle and then use hypotenuse. So you've got 6 there, and then you've got 6 here, and here as well. Essentially, you've got another right angled triangle. So you've got the hypotenuse is 6, the base is 3, and I've got that. So if I divide the base into 2 triangles, so you've got x equals the root of 6 squared minus 3 squared. giving us 3 root 3 for that length. We've got a base length and we've got the length of the hypotenuse, so you can find the height now. So you could say that I called it y. Y equals root of 6 squared minus 3 root 3 squared. Yeah, so I've got the height of it is 3 centimeters.
Okay.
And what else do we want? The angle between AB and the plane BCD. AB and BCD. Okay. Because this is equilateral, all the sides are 6. The angle would be the same even if you said AC to the plane BCD.
Okay.
I think you can use that angle. You've got 2 sides, so you just use its trigonometry. So 6, 3, yeah. So sine x equals the opposite over the hypotenuse. So sine x equals 3 over 6. So x equals sine to the minus 1 over half.
Mm-hmm.
You get 30. The angle is 30. And then the angle between plane ABC and the plane BCD. Okay. Well, again, I need another sketch. I think. BC. Angle. So you've got the center point. So again, you can use the right angle triangle. You know the height already, that's 3.
Okay.
The side, you don't know the side, but you know the base length is the center to find the base, so you yes, so you use Pythagoras to get the 1/3.
Sorry, are you stuck on this one?
I'm just trying to. Yeah, I'm a bit stuck, but I'm kind of thinking about what I could do. Should I just tell you where I've got to so far?
Yeah, okay, yeah.
So I've got so I just sketched the base of the BCD, and then you've got the side lengths are 6, and you know that half of the base length would be 3, and yeah, it's the height of it 3√3. Is that the total height?
So I think MD is 3√3.
Okay, and would M to the center be that? That would just be half of that, right?
Center of what? Oh, BCD?
Yeah.
To the middle of the triangle? Yeah.
So the halfway point between D to M, that's going to be half 3√3.
Yeah. 3√3
Okay.
over 2.
Yeah. That's. Oh yeah, because yeah. So you've got the right. So you've got the base length is 3√3 over 2, and you've got the height of it is 3. So I've got another right angle triangle here.
Okay.
It's the top of it would be A, and where the right angle is, it's going to be the midpoint. So I'll call it M.
Okay.
And then the far the vertex just opposite M it's between BC. So I don't think I need to label it as such, but the angle you want. So you've got the adjacent and the opposite. So you use tan. So tan x equals over the adjacent, opposite over the adjacent. So tan x equals 3/3√3 over 2. So 3 divided by 3√3 over 2. So that's the same as saying that tan x equals 3 times 2/√3. 2/3√3.
And can that be simplified?
Yeah. Yeah, and so you've got tan x equals 6. 2 3s are 6 over 3√3. So that's going to be the same as 2/√3, which is so 2/√3. So you have x equals tan to the minus 1 of 2/√3. So right. Would this be in a calculator paper, this question?
Yes.
Okay, that's fine. So then you can just use, so tan to the minus 1, so of 2/√3. And then you just get 49.11.
Let's say 49.1 degrees.
Okay.
that's it. Yeah, so I think just drawing a diagram helps. Any questions there?
2 seconds, sorry. That is 49.1. No questions there, that's fine. So that just is half of what. ABCD is a kite. AB equals AD. A circle can be drawn passing through A, B, C, and D. AC is the diameter of the circle. So I might just sketch a kind of a circle going around it.
Okay.
You want to prove it's a diameter, so you could draw another line going through D to B. That won't help you there. So you want
Yes, any idea how you started?
Yeah, I'm looking at it. I'm just trying to work out. So you've got. I've drawn a straight line from D to B.
Why is that?
So we need center point. I don't know how to do that.
So I think you would start by proving that they're congruent.
Okay.
Oh yeah, my next student is here now, unfortunately. So yeah, prove that they're congruent, and you would go from there.
Okay.
Yeah, how was that for you, Stefan?
That was good. Yeah, good.
Any questions for me in general? And so do you want to finish off those questions next time?
Yeah, I think so.
I think there weren't many. Yeah, all right, well done, Stefan. You did great. I look forward to talking to you again next time.
See you next week. Thank you.
All right, have a good week. Goodbye.